Hi, this lesson is about solving inequalities. What's an inequality? So we have the less than symbol, the less than or equal to symbol, the greater than symbol, and the greater than or equal to symbol. So we'll be solving inequalities. So instead of having an equal sign, we'll have one of these four symbols. Okay, but before we can actually solve them, we have to learn how to represent the answers properly. And there will be two different kinds of notation. First one is called set builder notation, and the second one is called interval notation. So we're going to using those notations before we solve. So here's our examples. Given the following number lines, express the shaded portion in both set builder and interval notation in terms of x. So what that means is we're going to let everything that you see that's shaded be represented by the variable x. So you can see here that this number line is shaded to the left of 4. And the further you go left on a number line means that your numbers are getting more and more negative. So this arrow means that it's approaching negative infinity. So in set builder notation, it's written like this. This is read as the set of all x such that x is less than 4. So less than 4 because we are shading to the left of the number line. And so that represents all numbers less than 4, but not including 4. So you don't use less than or equal, just less than. And the reason why you know that you're not including 4 is because I have this open circle here, meaning it looks like a point, but it's not colored in. So that means all values really close to 4 are included, but not 4 itself. And then we have our interval notation. An interval, again, represents a range of numbers, and you always write your interval from smallest to largest. So the smaller value here would be negative infinity, comma, and that means through 4. So this is a range of values from negative infinity to 4. When we do not want to include 4 because of that open circle, you put a parentheses. Okay, so let's move on to B. So in part B, this blue line, we are shading to the right. So this looks like we want all numbers greater than -1, but again, not including -1 because of the open circle. So with set builder notation, it's the set of all x such that x is greater than -4. Notice that the inequality symbol is pointing in the same direction that we are shading in. So we're shading to the right, the inequality symbol points to the right. And in the previous example, I had a less than symbol and we were shading to the left. So that will always be the case. Okay, so let's move on. With interval notation, again, always write your interval from smallest to largest. So since this is going towards positive infinity, you want to write your interval as -1, comma, infinity with parentheses around the interval. Okay, so here's another example. In this case, we are shading to the left, but it's different than the first example because I don't have an open circle. I have this one here that's colored in. That's considered to be a closed circle at 2. So that means I want all numbers from negative infinity all the way up to and including 2. So the way that's represented with interval notation is the set of all x such that x is less than or equal to 2. So let me explain a little bit more about this notation. These curly brackets at the beginning and the end, that's the part that I'm calling the set of. And then our variable is x, such that, that's this bar that you see here, such that x is, and then you'll have your inequality symbol, because we are shading to the left and we want to include 2, we use the less than or equal to symbol. All right, then interval notation. Remember, always write your interval from smallest to largest. So this goes from negative infinity to 2, but this time we want to include 2. So instead of a parentheses, we use this square bracket. The square bracket means to include 2 in the interval, which is different than what we did in the first example, which was a less than problem, but we did not want to include the 4, so we used parentheses. Okay, let's go on to part D, here in green. So we have this number line here. This looks like we are including all numbers greater than or equal to 0, or equal to because of the closed circle. So we definitely want to include 0. So set builder notation is the set of all x such that x is greater than or equal to 0. And your interval notation is from 0 to infinity. We want to include 0, so we put the square bracket in front of 0. Notice that infinity and negative infinity in every example always has a parentheses, never a square bracket around plus or minus infinity, because it's a concept, not an actual number. So whatever largest number you can think of, there's always a bigger one. So always put parentheses by infinity and by negative infinity. Okay, so these next two examples are a little bit different because we are shading in between two numbers. So here, part E, we have shaded between -3 and 1, but notice that at -3 I have an open circle and at 1 I have a closed circle. So that means I do not want to include 3, but I do want to include 1. So the way that's written is that you put your variable x in the middle of these two numbers because that's exactly what x is. It's this shaded portion in the middle. So it's the set of all x such that -3 is less than x, which is less than or equal to 1. So we use less than because of the open circle, but we use less than or equal to associated with the 1 because of the closed circle. Okay, now interval notation. Remember, always write your interval from smallest to largest. So -3 is the smaller number, 1 is the larger. -3 is not included, so we put a parentheses. 1 is included, so we put a bracket. Okay, F, similar. So here I'm shading between -1 and 5. -1 is included, 5 is not. So here's our set builder notation. It's the set of all x such that -1 is less than or equal. Less than or equal is because of the closed circle here. Less than or equal to x, which is less than 5. Just less than because 5 has an open circle. And then we have our interval notation. Remember, always write your interval from smallest to largest. And so we go from -1 to 5. Include -1 because of the closed circle, you put a bracket. Don't include 5 because of the open circle, put a parentheses. All right, so now let's go in the other direction. In these next examples, I'm giving you intervals and we're going to create the number line. So the first example is that we want to represent the interval from -1 to 4 on a number line. So that means that you want to shade to the left, negative infinity, all the way up to 4. I want to include 4, so we color in this point here. It's a closed circle, and you're done. Right, now let's look at part B. We want to show the interval from 2 to infinity. This time we should be shading to the right. Your numbers are getting larger and larger. We do not include the 2 because of the parentheses, so we put an open circle here. And then we shade to the right from 2 to infinity. Here's another example, part C. From negative infinity to -1. Again, this should be shading to the left. This is going towards negative infinity, all the way up to -1, but not including -1, so we put an open circle. And then finally, D, bracket -2 to infinity. We're shading to the right. Remember, this is going towards infinity. The square bracket means color in your point, closed point at -2. And then shade it to the right. Okay, so now that we know how to represent the solutions, let's do some inequalities, solve some inequalities. Solve and present your solution in interval notation for 2x plus 1 greater than or equal to 7. All right, so we solve inequalities the same way we solve our linear equations. We're going to subtract 1 from both sides of the equation. We want to isolate x on one side of the equation. So that leaves us with 2x is greater than or equal to 6, then divided by 2, and you get that x is greater than or equal to 3. So in interval notation, this would go from 3 to infinity, and because it's greater than or equal to, we want a square bracket in front of the 3. And you can check these the same way you check the way you would check your equations. You only have to check one value. So I'm going to pick a value greater than or equal to 3. So I'm going to let x equal to 5, and I'm going to plug that into the equation. So is 2 times 5 plus 1 greater than or equal to 7? Well, this is 11. 11 is definitely greater than or equal to 7, so it checks out. All right, here's another example. Solve and present your solution in interval notation. We have negative parentheses x plus 1 plus 4x is less than 5. So first we have to distribute the negative. So we get negative x minus 1 plus 4x. Then combine like terms in the next line. So we get 3x minus 1 is less than 5. Add 1 to both sides. We get 3x is less than 6. And we get the solution that x is less than 2. So in interval notation, that is all values from negative infinity to 2, but not including 2. So we have parentheses around that interval. Okay, so here's an example with fractions. So we want to solve 2/3 y plus 13/4 greater than 5/12 y minus 9/4 and present the solution in both set builder and interval notation. So when you have fractions like this in an inequality or in an equation, there's a quick way to eliminate the fractions by multiplying both sides by the lowest common denominator. So if I look at all my denominators, 3, 4, 12, and 4, the lowest common denominator is 12. So I'm going to multiply the left side and the right side by 12, which is what you see here. In the next line, I'm actually showing the distribution and the simplification. So every term gets multiplied by 12. And in every case, the denominator will cancel with the 12, which is the point of this technique. When I cancel, you end up with this inequality. So the fractions are gone. So I have 8y plus 39 is greater than 5y minus 27. Then I need to solve for y. So again, you want your variable on one side, your constant on the other. It is easier to manage these if you always end up with your variable on the left side of the inequality. But I'll explain later what you need to do if it ends up on the right. So I'm going to end up with my variable on the left side. So in this line, I subtracted 5y from both sides of the equation of the inequality. So I get 3y plus 39 is greater than negative 27. And then subtract 39 from both sides and you get 3y is greater than negative 66. Divided by 3 and you get that y is greater than negative 22. So in set builder notation, that's this one right here, it's the set of all y such that y is greater than negative 22. And in interval notation, which is the second one, it is the interval from negative 22 to infinity, but not including negative 22. So we use parentheses. Make sure you know the difference between set builder and interval notation. Okay, so there'll be two rules dealing with inequalities, and this is the first one. When multiplying or dividing an inequality by a negative number, you must switch an inequality to its opposite inequality. So what are opposites? So the first opposites are less than and greater than are opposites. So this one being the less than symbol, and this one being the greater than symbol. So if you get those mixed up, that's going to be a problem. So practice understanding the difference between these two symbols. The less than symbol sort of looks like an L, so that might help you. And then the other opposites are less than or equal to, and the other opposite, the opposite to less than or equal to is greater than or equal to. So if we have to multiply or divide both sides of an inequality by a negative number, we switch the inequality to its opposite. All of the previous examples, we have not multiplied or divided by a negative number, so we didn't have to apply this rule. But now let's practice this. Here, solve and express an interval notation. Let's start with A. We have negative 2x is greater than 8. So here we have to divide by a negative number, which is negative 2, in order to solve for x. Notice that when I divide by that negative number, my greater than symbol got switched to a less than symbol because they're opposites. And then simplify, and you get that x is less than negative 4. So that's represented as the interval from negative 4 to from negative infinity to negative 4 with parentheses around the interval. Okay, let's go on to part B. We need to solve negative parentheses 3x minus 1 greater than or equal to negative 8. So first I distributed the negative, so I have negative 3x plus 1 is greater than or equal to negative 8. Then I want to isolate my x by subtracting 1, which leaves me with negative 3x is greater than or equal to negative 9. Then I divide both sides by negative 3, and when I did that, notice that my greater than or equal to switched to less than or equal. And then that leaves us with x is less than or equal to 3. So that represents all numbers from negative infinity to 3, including 3, so we put a bracket around the 3. Okay, let's move on. Part C here in blue. I want to solve 3x minus 6 less than 4x plus 1. So again, you want your x's on one side, your constants on the other. So I subtract 4x first from both sides. And so I get negative x minus 6 is less than 1. Then add 6 to both sides, so you get negative x is less than 7. Then here, I don't want negative x, so I'm going to divide both sides by a negative 1. So my less than turns into a greater than, and you get that x is greater than negative 7. Okay, and an interval notation, that's the interval from negative 7 to infinity. Again, greater than means that numbers are getting larger and larger. Don't include negative 7, so put parentheses around the interval. All right, here's D. We want to solve negative 2 times z plus 1 less than or equal to negative 10. So first I distributed the negative 2, so I have negative 2z minus 2 is less than or equal to negative 10. Add 2 to both sides, you get negative 2z is less than or equal to negative 8. Divide both sides by negative 2, and again, once you do that, my less than or equal to becomes a greater than or equal to. Simplify, and you get that z is greater than or equal to 4. So your interval, your interval is the interval from 4 to infinity, and you want to include the 4, so you put a bracket around the 4. All right, so here's another rule. If when solving an inequality, if the variable ends up on the right side of the inequality, then you must switch the variable and the constant and switch the inequality to its opposite. So this will happen if when you're doing your work, if your variable ends up on the right, you always want to read your inequality from left to right. So x is whatever the inequality is, less than or equal, greater than or equal to some number. You don't want the variable on the right. So this is how we fix it. So we want to solve and express in set builder and interval notation, and then graph the solution of x plus 2 greater than 5x minus 10. All right, so first thing I did was I subtracted x from both sides so that my x's end up on the right, like you see here. So I have 2 is greater than 4x minus 10. Then I want to move the minus 10 over to the left, so you add 10 and you get 12 is greater than 4x. Then divide both sides by 4 and you get 3 is greater than x. But like I mentioned, you want to write the x on the left and the constant on the right. So when you do that manipulation, the x and the 3 switch places, but so does the inequality. The greater than turns into a less than symbol. So in set builder notation, it's the set of all x such that x is less than 3. In interval notation, it's from negative infinity to 3. And in terms of the number line, you want to shade to the left of 3, but not include the 3, so you put an open circle there. And just like I mentioned in the past, you can check this. So suppose I want to check some number less than 3. So let's check 0. You can pick any number less than 3, plug it into the original inequality. Is that equal to, less than the right side? So 2 is definitely less than, oh, I'm sorry, I wrote this down wrong. It's a greater than symbol at the beginning. Sorry about that. So we want to check if this is greater than the right side. 2 is definitely greater than negative 10, so it checks out. Right? I wrote down the wrong symbol. All right, so let's move on. So here we want to solve and express the answer in both step builder and interval notation. And our problem is 8 minus 7 times x minus 5 less than or equal to 2x plus 16. So first thing I did was distribute the negative 7. So I get 8 minus 7x plus 35 less than or equal to 2x plus 16. Then I get negative 7x, 8 and 35 is 43, less than or equal to 2x plus 16. Then I'm going to move the negative 7x over to the right by adding it. So I have 43 is less than or equal to 9x plus 16. Then I want to subtract 16 from both sides. That leaves me with 27, less than or equal to 9x. Divide both sides by 9, and you get 3 is less than or equal to x. Similar to the last example, switch the x and the 3, flip the inequality, so that is the same as x is greater than or equal to 3. So in set builder notation, it's the set of all x such that x is greater than or equal to 3. And in interval notation, it's a square bracket because we want to include the 3 all the way to infinity. So that's it for this lesson. You should try the homework. Good luck.